Self-induction. According to Faraday's law, the change in flux through a coil by any means induces an EMF in it. In our examples we have discussed so far, induced EMF was produced by a changing magnetic flux from some external force. But the change in flux through a coil may also be due to the change in current in the coil itself. Consider a circuit shown in figure 15.12. The coil is connected in series with a battery and a rheostat. Magnetic flux is produced through the coil due to current in it. Magnetic flux is produced. The coil is connected in series with a battery and a rheostat. Magnetic flux is produced through the coil due to current in it. If the current is changed by varying the rheostat quickly, magnetic flux through the coil changes. That causes the induced EMF in the coil. Such an EMF is called self-induced EMF. Magnetic flux is produced magnetic flux is produced through the coil due to current in it. If the magnetic flux is changed by varying the rheostat quickly, the magnetic flux through the coil changes, causing an induced EMF in the coil. Such an EMF is called self-induced EMF. The phenomenon in which changing current in a coil induces an EMF in itself is called self-induction. If the flux through one loop of the coil be phi, then the total flux through the coil of n turns would be n phi, as phi is proportional to the magnetic field, which in turn is proportional to the current. Therefore, n phi is directly proportional to I, n phi is equals to Li, where L is the constant of proportionality called as the self-inductance of the coil. Enjoying till now? Cool. It depends upon the number of turns of the coil. Its area of cross-section in the core material by winding the coil through the ferromagnetic iron core. The magnetic flux and hence the inductance can be decreased significantly relative to the of an air core. I guess that's enough for right now. Gonna torture everybody someday. Other than today.